in figuring out the delta, you'll have to figure out the delta NaN gap, which is NaN gap minus 12, which tells you 12 is normal, maximum normal NaN gap. So this tells you how much NaN gap you have above normal, more than normal. And in figuring out the delta bicarb, you subtract from 24, you subtract the actual bicarb, and this tells you how much drop in bicarb happened to this patient from normal. 24 is normal. Usually, if your NaN gap goes up by 4 points, let's say, then the bicarb will drop by 4 points. So if you subtract the two, you'll end up with 0, which means there is no unnecessary amount of bicarb there, and there is no unexplained loss of bicarb there. So in figuring out the delta, if the delta NaN gap is bigger than the delta bicarb, that means the person has more bicarb than necessary, which means there is a metabolic alkalosis. But in the case we just looked at, the delta NaN gap was smaller than the delta bicarb, which means the person has lost more bicarb than is explained by the NaN gap, which means they have a metabolic acidosis that is non-gap on top of the NaN gap metabolic acidosis. As far as the third primary, I'm going to apply delta. Delta NaN gap means the NaN gap minus 12, and delta bicarb is 24 minus bicarb. The NaN gap, if you go back a couple of slides, was 22 minus 12 is 10, and the bicarb here is 12, so 24 minus 12 is 12. 10 minus 12 equals minus 2. Because it's a negative number, there is a metabolic acidosis that is non-gap in addition to the NaN gap metabolic acidosis. So there is NaN gap metabolic acidosis and non-NaN gap metabolic acidosis as the third primary. Of course, there is no second primary here, so you're going to say NaN gap metabolic acidosis is the second primary and non-gap acidosis is the third primary.